geometry students, in this video we will be starting chapter 10, okay? Now this is a chapter about circles. We're going to be looking at parts of circles and other stuff probably that you didn't even know existed, okay? We're definitely going to study old material that you've known, for many years, like radius and diameter and circumference and area and all of that. But we're also going to be looking at stuff that you might not know a lot about. Chords, arcs, tangents, secants, common internal tangents, common external tangents, etc. So it's going to be a lot of stuff we're going to learn in this chapter, and the chapter is primarily about circles, okay? Now, continuing on, your heading for today is circles, okay? Lesson 10.1, circles, lesson 10.1, and be sure to include today's date so that your notes are organized, okay? So your heading today is circles, lesson 10.1, and be sure to include today's date. Let's start off with a simple definition of the term circle, okay? You're responsible for this definition, so please copy it down. Here it is. A circle is the set of all points that are equidistant or that are the same distance from a given point called the center, okay? The set of all points that are equidistant from a given point called the center. So please copy that in your notes, okay? Copy that down, please. The set of all points that are equidistant from a given point called the center. And to be honest with you students, to me, that definition makes total sense. You don't have to copy this down, but just watch while you're finishing up your definition. I mean, if you think about it, a circle is a bunch of points, millions of points that are side by side so close that you can't even actually see them, okay? That they're so close they actually make up a circle. So this whole circle right here is made up of little points, okay? And every single one of those points that lies on the circle is the same distance from a point called the center. And so there you go. That's what the definition of a circle is, okay? The set of all points that are equidistant from a given point called the center, okay? Now, here's the symbol used for circles, so please make note of this. It's very important that you know this. If I have a triangle like this, triangle ABC, I symbolize that by saying triangle ABC. Okay, so if I have a circle like this, copy this in your notes, please. And I have a center called P. I symbolize that by putting a little circle. You put a dot in the middle, and you put the letter P. That means circle P. Okay? So it is important, students, that you understand how to symbolize a circle or how to write it, just like we did with triangles up here. Also, students, it's very important that you understand that a circle is always named by its center. Okay, if we have a point right here called point A, we're not going to call this circle A. We're going to call it circle P. A circle is always named by its center. A triangle was always named by its three vertices. Okay? A circle is named by its center. Alright, let's continue on. There are some really, really important terms that will be used throughout the entire chapter. Let's go over these now, and students, I'm telling you, if you don't know these, I can guarantee you one thing. I'm not being mean to you, but I can guarantee that you'll be lost the rest of the chapter. Because when I start talking about chords and secants and tangents and all of these different things we're going to talk about here in a second, if you don't know what that means, you're going to have no idea what the theorem is saying, because you're not going to know what the terms mean inside the theorem. So it's very important you know these 12 terms. Now, I'm not going to make you memorize them. They're not going to be fill in the blanks on your test, okay? Excuse me. But you still have to know them. So here we go. Please copy these down, okay? In your notes, I'd like you to draw a circle like this, okay? Draw a good size circle. And then put up here at the top, leave spaces up top for all of these words, okay? And then write down interior of a circle, okay? So draw a circle, and then write interior of a circle. And let me pause and say this. I'm going to go a little fast. There will be plenty of times where you're probably going to ask the supervising teacher to pause the video, okay? Which is fine, okay? Here we go, interior of a circle. Well, you can probably figure out what that inside. So go ahead and put point A right here. And then come up here and put point A. Any point that lies inside the circle, we say is a point on the interior of the circle. Okay? So any point that's inside the circle is on the interior of a circle. Anything inside of this circle, all of this is called the interior of the circle. Got it? Okay, moving on. I'd like you to write in your notes exterior of a circle. We'll put a point over here and we'll call it point B, okay? Point B lies in the exterior of a circle because all of this space that's on the outside of the circle, we call that the exterior of the circle. So please make note of that. Now, Mr. Earhart, what about the actual points that aren't on the inside or the outside? They lie right here. They lie right on this circle here. Well, that's it. I can't draw very well, but you get the point. Those points are the actual circle themselves. So they're not in the interior. They're not in the exterior. They are the actual circle themselves, okay? Now, I would like you to go ahead and draw a line in your notes. We'll draw it from here to here, or a segment, okay? There we go. And hold on one second, it's really hard to draw this with a mimeopad. Okay, so we're going to call this C, D, okay? So a chord is, an example of a chord would be segment CD. So write that in your notes, please. So a chord is any segment that lies inside the circle and intersects two sides of the circle like this. Now I could give you a lot fancier of a definition and make you memorize it, but I don't think I need to do that, guys. I don't want to make you memorize a bunch of stuff when I don't need to, okay? And you can see a chord is this. A diameter would be a chord, right? Because a diameter runs from here to here and goes to the center. This would be a chord. This would be a chord. This would be a chord. Any segment whose endpoints lie on the circle is a chord. Okay? Any segment whose endpoints lie on the circle, like CD, is a chord. So please understand what a chord is, okay? Okay, students, let's continue on. Write the word diameter in your notes. Let's put a point here, and then we'll draw a line going straight across, and a line going straight across from here. Alright, so let's call this EF, and we will call the center of the circle G. Okay, so in this example here, I have diameter EF. So, listen, students, a diameter is just a chord, but it's a special chord. It's a chord that passes through the center of the circle. Let me say that again. A diameter is a chord that passes through the center of the circle. Now, all of these definitions that I'm reading out loud, you do not need to write those down. You do not need to know them. I'm just trying to explain to you what a chord is and what a diameter is. A diameter is a chord that passes through the center of the circle. Now, every diameter is also a chord, but not every chord is a diameter. Sometimes a chord will be a diameter, sometimes it won't be. See this chord CD right here? That's not a diameter, is it? Of course it's not. So there's a chord that's not a diameter. However, if I give you a diameter is always a chord. Okay? So diameter EF is also called chord EF. And once again, a diameter is a chord that passes through the center of a circle. Now let's talk about the radius of a circle. I'm going to go ahead and draw a line from here to the center. And I'm going to call this point right here H. Okay, so GH is a radius. But you know what else? EG is a radius. So make note of that. Also, GF is a radius. All three of those segments are radii. Now, plural for radius is not radiuses, okay? Just so you know, the plural for radius is radii. So you would say all three of these are radii, okay? Alright, now let's continue on. So diameter and radius should pretty much be review, okay? Alright, now let's talk about a tangent line. Now let me stop and say that a tangent line has nothing to do was SOHCAHTOA, opposite over adjacent, sine, cosine, tangent, nothing, no relationship, nothing, okay? Having said that, let me show you what a tangent line is, okay? A tangent line is a line drawn in such a way that it intersects the circle in one place. So do the best you can, your nose, to draw a line like I just did. And I know you guys are jealous of my awesome drawing skills. And we're going to go ahead and put the letter I right here where the line intersects the circle. That line is called a tangent line. Let's call this line M. So go ahead and put an M right here. Okay? A little cursive or script M. So this line here is called a tangent line. Alright? Now, pretty simple. If a line intersects a circle in one place, we call it a tangent line. Now the point of tangency is where that line intersects the circle. For example, this line right here is a tangent line. It intersects the circle in one place. What point does line M intersect the circle? Point I. So, point I is your point of tangency. Isn't that easy? That's a piece of cake, guys. I mean, most of these are just common sense. I mean, point of tangency, that's where the tangent line touches the circle. It's a point. Exterior of a circle on the outside, interior on the inside. Okay? Now, a secant line. Now, a secant line, please copy this in your notes. A secant line is a line that goes through the circle and intersects it in two places, like this. Let's draw it right here. Here's a secant line. Go ahead and draw that in your notes, please. And we're going to go ahead and give 2 points right here. And let's see, let's call them J, points J and K. Alright? Now I'm going to talk to you about this for a minute, so please listen carefully. First of all, is the secant line in this circle would be line, and be sure and put line, okay? Line, J, K, okay? But students, listen, let me stop. So do you see what a secant line is? It's any line that intersects the circle in two places. Do you see what a tangent line is? A tangent line is any line that intersects the circle in one place. Know that. Memorize it. Be familiar with that, okay? Now, having said that, look, notice the secant line passes through the circle in two places. Now, but anytime, listen guys, anytime you have a secant line, you also have a chord. Because if a line passes through the circle in two different places, then it forms an automatic chord right here. And we call that chord J, K. Segment JK. So anytime you have a line that passes through the circle in two places, the entire line is called the secant line, and this little segment part that goes from here to here, we call that a chord, because it is a chord. It's a segment whose endpoints lie on the circle. Hope that makes sense. Now let's talk about a common tangent, okay? A common tangent. Copy that in your notes, common tangent. Now before I show you what a common tangent is, I want to warn you, I'm getting ready to erase all of this stuff right here, okay? So if you're not done copying all that, pause the video, get it all copied down, and then restart the video, because I am going to erase this now, okay? Alright, now let's talk about common tangents. Alright, common tangents. Now, anytime that you have a line that is tangent to two circles, and you understand it's going to be really hard to draw, okay? So just let me be the really poor drawer that I am. Yeah, that's not going to work. Okay, not too shabby. Alright, now. Alright, so go ahead and draw that in your notes, please. You can continue to use the same circle that had all of the stuff on the inside, or you can draw another circle and another circle. That's up to you. But anytime a line is tangent to two circles, we call that a common tangent. So let's go with JK. We'll call this L and M. So line LM is an example of a common tangent. Do you see that okay? Alright. A line circles is a common tangent. Alright, how did that happen? Now, let's continue on. Let's talk about a common external tangent, okay? A common external tangent is a common tangent. Now, this is going to be confusing. I'm going to read it to you, and then I'm going to give you an example of it, okay? A common external tangent is a common tangent that does not intersect the segment that joins the centers of the circle, okay? Now, here's my center, okay? Here's my center. Pretend there's a line drawn here, okay? If I were to draw, if I had a common tangent up here, and then another common tangent down here, which I'm trying to draw now like this. And you can also do this in your notes, guys, the best you can, okay? Now watch this carefully. Alright, now I have a common tangent LM right up here, and now I have a common tangent NO, okay? Now, listen to me carefully. I'm kind of laughing because this is not easy to say, okay? Whenever you have two common tangents, here's one and here's one, okay? Now listen to me. And these two tangents do not intersect. This line drawn from the center of one circle to the center of the other circle, then we call these two tangents common external tangents. Let me say that again. This is not easy to understand, so take good notes and listen, okay? This is a common tangent. How do I know that? Because it's tangent. This line is tangent to how many circles? 2 circles. This is a common tangent. How do I know that? Because it's a line that's tangent to how many circles? 2 circles. These two common tangents together make up what we call common external tangents, okay? And we know that we have that when when a common tangent does not intersect this line right here, okay? This line drawn from the center of one circle to a center of another. Now, take notes whenever you want to, but now watch this. When I take this line here, let's just watch this. Well, let me do this instead. When I have a line that goes like this, now watch this really carefully, students, please. Take some good notes on this, okay? Now look at this tangent line. We'll call this one line PQ. Do you see it right here? Now look, guys, do you see how line PQ is a common tangent? I mean, it really is. It is a line tangent to 2 circles. It intersects this circle here at point P, and it intersects this circle here at point Q. Do you see it okay? But what's special about this tangent is it's intersecting this imaginary line that connects the center of one circle to the center of another circle. And by the way, you do not have to have this red line drawn in order to have an common internal tangent, okay? But if this line was drawn from one center of a circle to the other center of the other circle, and there's a tangent that goes like this and crosses that line, we call this tangent a common internal tangent, okay? So this line here is a common tangent, okay? It's also called a common external tangent. This line here is a common tangent, but it's also called a common internal tangent because it crosses this line that's formed from the center of one circle to the center of the other circle, okay? This line here is a common tangent because it's tangent to 2 circles, but it's also called a common external tangent because it lies on the outside of this line right here. It's not going to intersect this line right here. Common external tangent, common external tangent, common internal tangent. And all 3 of these are just plain old common tangents, okay? Alright, I hope that makes sense. Let's go ahead and continue on. Now next, text somewhere in your notes. I'm getting ready to erase all this, students, so pause the video if you need to, okay? Now, last but not least, and we're finally finished with all these terms. Let me get rid of this right here real quick, guys. Concentric circles. It's so easy, guys. Maybe the easiest thing we're going to look at today, maybe. Concentric circles are just circles that have the same center. So, if I pick up this circle and put it right in the middle of the other circle like this, alright? Then, let me do this. Let's call this a red circle, and we'll call the other circle a black circle. The center of the red circle is right here, but the center of the black circle is also right here. So we call these two circles concentric circles. Now you take notes on that however you want to. I'll pause a second while you write that down. But concentric circles are circles that have the same center. It's that simple. They have the same center. Okay? Alright, moving on. Now, let's finish up with this and we're finished. What are congruent circles? If I say those two circles are congruent, what does that mean? It means they have the same radius or diameter, either one, okay? So if two circles have the same radius, then they're congruent. If two circles have the same diameter, then they're circle. And you're like, well, Mr. Earhart, duh. I mean, if two circles have a diameter of 10, then their radius is going to be 5. I know that, but I want to be very thorough in my definitions, and you do need to know this, so write this down. This is one definition you need to know. I want to be very thorough in my definitions, so I'm going to cover all the aspects, okay? Congruent circles are circles that have either the same radius or the same diameter. Okay, that's it, guys. I hope this video has made sense. If you have any questions, don't hesitate to call